Welcome to this video on estimating the population proportion. The lesson goals for this video are, first of all, to construct a confidence interval denoted by CI for a population proportion, and then to determine the minimum sample size for a particular confidence level and margin of error. Why we need a confidence interval for a population proportion is all about estimating population attributes. An attribute is a characteristic that members of a population either possess or do not possess. Attributes are almost always measured as the proportion of the population that possesses the characteristic. Estimating the proportion of the population that possesses an attribute is straightforward. A random sample is selected and the sample proportion is computed as follows. X is the number in the sample that possess the attribute, N is the sample size, and then X over N, or X divided by N, is the proportion or fraction in the sample that possess the attribute. Population versus sample proportion, the symbol P, just a lowercase p, indicates the proportion of the population that possess the given attribute. The symbol P hat, lowercase p with a circumflex on top of it, is the proportion in the sample that possess the attribute. So P hat is this X divided by N, this X over N, the number in the sample that possess the attribute divided by the sample size. And that gives you the percentage or fraction or decimal corresponding to the proportion of the sample that has this characteristic. So the steps for constructing a confidence interval for a population proportion are, first of all, to find a critical value, z sub alpha over 2, where alpha is the complement of the confidence level that you want. The confidence level that you want we denote by C for confidence, and it's a percentage corresponding to a probability, and alpha is the complement of that percentage. So alpha is 1 minus C, or 100% minus C as a percent. Second step is to calculate the margin of error. This value E is the critical value z sub alpha over 2 times a standard deviation, sigma sub p hat, where sigma sub p hat is calculated by taking big square root of p hat times 1 minus p hat over n. Then finally we add and subtract the margin of error to and from the sample proportion, p hat, to get the endpoints of the interval. For example, constructing a confidence interval for a population proportion, suppose a sample of 410 randomly selected radio listeners revealed that 48 listened to WJLN. Find a 95% confidence interval for the proportion of radio listeners that listen to WJLN. All right, so you need to notice that we have a sample size, N, of 410. The characteristic or attribute that we're looking at here is whether or not radio listeners listened to WJLN, this one station. So 48 is the count, which we denote by X from the sample, and the sample proportion then is 48 out of 410. Then, since we want a 95% confidence interval, C is 0.95, and then alpha, the complement of that, is 1 minus 0.95 or 0.05, and so half of alpha, alpha over 2, is 0.025. So then from a z-score table or from the TI-8384 calculator, you take the absolute value, the positive, of inverse norm of 0.025 to get this critical value, z sub 0.025, which is 1.96, almost 2 standard deviations to the right of the mean. We calculate p hat, 48 out of 410, or 48 divided by 410 gives us a decimal rounded of 0.1171. So then the standard deviation, sigma sub p hat, is the big square root of 0.1171 times 1 minus 0.1171 divided by 410. And that should come out to approximately 0.0159. So E, the margin of error, is 1.96. the critical value, times 0.0159, the standard deviation, which comes to 0.0312. So we've got about a 3.12% margin of error. So then the endpoints of the confidence interval you get by adding and subtracting that to and from p hat, 0.1171 minus 0.0312 and 0.1171 plus 0.0312, and that gives the 95% confidence interval for p, which is 0.0859 to 0.1483. In other words, about 8.59% to 14.83% is the interval that has a 95% confidence for capturing the population proportion of radio listeners that listen to WJLN. You could also view that as the sample proportion, 11.71%, plus or minus the margin of error, 3.12%. And this interval can also be found with the TI-83 84 calculator. You can use the one-prop-z-int function that is found under the Stat button, the Tests menu. And there you just put in x and n and c, and it gives you the interval. For determining sample size, we use a formula that is basically the margin of error formula solved algebraically for n. So n is the critical value, z sub alpha over 2, squared, times p times 1 minus p, divided by the margin of error squared. So this gives us what n needs to be to have a desired confidence level and a desired margin of error. We want to be a certain percent confident, and we want to be within a certain margin of error. How big of a sample size do we need? So here we need to either approximate or have an estimate for p. Otherwise, we can use 0.5 and just assume that there's a 50-50 chance. And when you calculate n with this formula, you just have to round up to the next whole number, because this gives a minimum sample size required, and of course sample size is always a whole number. So you just always round up, and that gives you your necessary sample size. Thank you for watching this video on estimating a population proportion. I hope you found it helpful.